Dear students, let us begin today's session from solid state, physical chemistry, first chapter. Before letting into solid state, you should know first of all what is meant by matter. What is meant by matter? Matter is anything which occupies space and has mass is known as matter. Generally, matter can be classified, physically classified into solid, liquid and gaseous state. Other than that, solid, liquid and gas, plasma and Bose-Einstein condensate. These are some other classification of matter. Main classification based on their intermolecular forces between the atoms in the matter. The intermolecular force of attraction is more, that and all comes under solid. Intermolecular force of attraction is less, we can say they are liquid. Very weak intermolecular force of attraction between the constituent particle which are present in the matter is known as gases. Generally, how and why we can classify this into solid, liquid and gas. First of all, how they classified into solid, liquid and gas. Just you have to see something that is matter. It seems to be, that is a fixed, it seems to be solid. It seems to be solid means intermolecular forces are more. It is going to occupy one particular position. It cannot flow. It seems to cannot be flow. That and all comes under solid. If it can flow means that is liquid. It can flow very faster. It is far apart from each other. Molecules are far apart from each other means that is comes under gases. Now we can come to the heading of solids. The solids are the substances which have definite volume and definite shape. Some of the important characteristic properties of solids are: solids have definite mass, volume and shape. The intermolecular distance in solids are short and intermolecular forces are strong. The distance between two molecules in the solid state is less. They are closely packed. We can say in solids atoms or molecule, that is otherwise called as atoms or ions or molecule. General term which is used to indicate atom, ions or molecule is known as constituent particles. The constituent particles are closely packed. They are closely arranged means that is comes under solid. They are loosely packed means liquid. They are far apart from each other means that is comes under gases. That solid state, the constituent particles of solids have fixed position and can only oscillate about their mean positions. Oscillate about only their mean position. The position is fixed in the particles of solids. But a liquid's position is not that much fixed. In gases, position never fixed. It is always in movement. Gas molecules or gas particles are always in a movement. Next one is density of solid is greater than that of the liquid and the gases. Solids are almost incompressible and rigid. Liquid we can compress to some extent, gases are highly compressible. Solids diffuses very slow as compared to liquid and gases. These are some important characteristics of solid. And last point of characteristics of solid. Most solid becomes liquid when heated. This process is known as melting. And the temperature at which solid changes into a liquid is called melting point. The melting point of solid depends upon the nature of the solid, and the melting point of the solid vary widely from one solid to another. The melting points of the solids are vary from one solid to another. Next one, classification of solids. Generally, solids can be classified based on the nature of order present in the arrangement of constituent particles. How the constituent particles are arranged in the solid. Based on that, we can classify the solid mainly into two types. One is crystalline solid, another one is amorphous solid. What is meant by crystalline solid? Crystalline solid, the substance whose constituent particles are arranged. Here constituent particle indicate either it may be atom, ion or molecule. They are arranged in a definite geometry pattern in three-dimensional space, are called crystalline solid. Here in the case of crystalline solid, the constituent particles are arranged in a regular manner throughout the crystal. It is this arrangement in three-dimensional space. They are arranged in a regular manner, means that type of solids comes under crystalline solid. For example, crystalline quartz. This is an example for crystalline solid. Crystalline quartz. In the crystalline quartz, you can see the atoms are arranged in a regular manner. Here there is one atom is present, which is denoted with a red color. Another one is blue color. The alternate positions are red, blue, red, blue, red. Like that, the arrangement is regular. That red indicate one kind of atom present in the solid. Another red, blue indicate another type. There are two different types of atom arranged in the crystal. Suppose you have to consider in quartz glass is consist of silicon dioxide. Quartz usually. Silicon atoms and oxygen atoms are arranged in a regular manner. This arrangement is three-dimensional. But here I drawn only two-dimensional, but is arranged in a three-dimensional. Atoms or constituent particles are arranged in a three-dimensional space. They are called as crystalline solids. And the crystalline solid, the three-dimensional regular arrangement is continuous for the long distance. That throughout the crystal, the arrangement is regular. That arrangement is known as long-range ordered arrangement. It is not for that some distance. Throughout the crystal, the arrangement is regular. So we can say this arrangement is known as long-range ordered arrangement. Next classification is amorphous solid. Amorphous solid, the substance whose constituent particles are not arranged in any regular arrangement, are called amorphous solid. They are not arranged in any regular manner. They are arranged in irregular manner. That regular, so some extent it is irregular. That regularity cannot be extended throughout the crystal. Some extent only the regularity is found in the case of the amorphous solid. There is no long range order arrangement. But in the case of crystalline solid, the arrangement is long range arrangement. In amorphous solids, there is no long range arrangement. Otherwise, it is known as short range ordered arrangement only. The ordered which type of ordered arrangement in the case of amorphous solid? Only short range order arrangement in the amorphous solid. Quartz glass is example. Quartz is example for crystalline. It's very, very important. Quartz is example for crystalline. Quartz glass is example for amorphous. Quartz glass is, that is a silicon dioxide. The glass which is made up of silicon dioxide is known as quartz glass. Glass is example for amorphous solid. Glass, rubber, plastic, that and all example for amorphous solid. In rubber and all, the atoms arranged in a regular manner, but it is not extended for a long. The same pattern arrangement cannot be found throughout the substance. That and all comes under amorphous solid. Now, what are all the main difference between the properties of crystalline solids and amorphous solid? The first property is shape. In the crystalline solid, definite characteristic geometrical shape because of order arrangement of constituent in a three-dimensional space. Suppose you are arranging some particle in a regular manner, means we can get one particular structure. Suppose you are not at all arranging in a regular manner, you are arranging that in a irregular manner, means we can't define the shape of that anything. Suppose you are arranging something that is either you are arranging with that is fixings, that is a student. Children are playing with some mold, that and all. You just pick an alphabetical order they are fixing. A means it has some structure. So we can identify that is A. B means it has some structure. We can identify it's a B. Without any structure, you just make them to hold together for a long extent, means we can't define the structure. The same thing only happen in the case of crystalline as well as amorphous solids also. In the crystalline solids, the atoms are arranged in a regular manner. That arrangement is three-dimensional throughout the crystal, so that we are getting definite geometry for the crystalline solid. In the case of amorphous solid, this arrangement is not that much regular. Suppose the regular arrangement is found, means that cannot be expanded throughout the crystal. Very short range only that regular arrangement is found in the case of that amorphous solid. That is a main difference between, so that we are not define the shape of this amorphous solid. Amorphous solid shape we can't fix it. This is a shape of this amorphous solid, like that we can fix it. So we can mold it to any different shapes. We can mold it in any different shape in the case of amorphous solid. Rubber means rubber, we can mold it in a different shape. Different, nowadays they are using some colored rubbers are we are getting by adding colors, as well as different shape rubbers we are getting nowadays. Just you can come to that eraser. Eraser is also is made up of the rubber. We are getting that in different shape. But in the case of pencil or pen, they are that almost that is comes under crystalline. Here plastic also, plastic we can remold it. The pen and all it comes under, that is an amorphous only. We can remold it as well as we can change the shape of soap. So where and all we can change the shape according to your need, that and all comes under amorphous solid. We can change the shape of some compounds, that is some substance. They are comes under crystalline. That is the main difference between the shape of the crystalline and amorphous solid. Definite characteristic geometrical shape because of ordered arrangement of constituent in the three-dimensional space in the case of crystalline solid. But in the amorphous solids, irregular shape, they do not possess any regular arrangement of constituent particles, and therefore they do not have definite geometrical shape. This is the main difference between crystalline solid and a amorphous solid. Next one is come to the melting point. Melting point in the case of crystalline solid, the melting at a sharp and characteristic temperature. The melt at a sharp, that melting point is very sharp for this crystalline solid. The melt at a sharp and characteristic temperature. It reaches that particular temperature, means immediately it get converted into liquid. All atoms are get collapse. Because it is regularly arrangement. Suppose you are arranging the things in a regular manner, you just pick any one of the, suppose you are arranging the balls in a regular manner, you can think that is in shop. I will give an example, simple example for you to understand that melting point. In the fruit shop, that is fruits and all arranged in the shelf. In that shelf, they placed some fruits in the top pillar. You can take example of orange itself. Orange and all, it is arranged in a regular manner in a shelf. In the middle, suppose they are following some method, you just observe it in the fruit shop, means it will be very clear for you. Suppose next time you are going to the fruit shop, means you just view that what is going on there. They are taking that fruit from that one ordered manner. They take it from the top layer. Suppose they will pick any one of the fruit from the middle, means what happened? All the fruit get automatically, that is a possibility for all fruit can fall down. To avoid that only, they are following one particular method to pick the fruit from the shelf. That we can say that as a shelf like that only, that arrangement. In the middle, we can pick any fruit from the middle, means everything get to collapse. Because the arrangement is ordered regular arrangement. Like that only atoms are arranged in the case of crystalline solid. In amorphous solid, atoms are arranged in a irregular manner. Wherever we can take, it is not going to be affect the melting point. It is not at all having any sharp melting point. In crystalline solid, you just pick up one atom, that is while heating, one atom get excited from its lattice point. All the atoms are get collapsed, they immediately get converted into liquid state. But in the case of amorphous solid, it is not like that. The gradual soft and over a range of temperature. For example, when a glass is heated gradually, it softened and started to flow without undergoing definite abrupt change into the liquid state. Therefore, glasses can be molded and given any desired shape. Just now only, that is the last point only, I indicated that in the case of amorphous solid, we can remold it to any shape. Because it has wide range of temperature. There is a melting point, wide range of melting point, melting temperature. But in the case of crystalline, once you just destroy that, once you just break the ordered arrangement of the crystalline solid, we can't arrange it again. It is somewhat difficult only. That only. So, due to that regular arrangement of constituent in that lattice, lattice means space where atoms are arranged in a regular manner. The three-dimensional space is known as lattice space. Lattice space. The space means the area where that atoms are arranged. That only space. In that lattice space, the atoms are arranged in a regular manner. Because of that, it shows the sharp melting point. Amorphous substance atoms are not arranged in a regular manner, irregular manner. Next point is heat of fusion. They have definite and characteristic heat of fusion, crystalline solid. Amorphous solid, they do not have any definite heat of fusion. And next, ordered arrangement of constituent particle. Crystalline solid, long range ordered arrangement. In the case of amorphous solid, only short range ordered arrangement. Next difference is that there is a cleavage property. When cut with a sharp edge of crystalline, you just take one crystalline solid. When the crystalline solid is cut with a sharp edged tool, they split into two pieces and they newly generated the surface and planes and smooth. Newly generated surface or plane and smooth. Newly generated, it will form a new, it get cutted into two different species. In that pieces, that each and every piece there is a new generation of surface or plane, surfaces or plane. The new generated surfaces are plane and smooth. New surfaces are plane and smooth. That is in the case of crystalline solid. Amorphous solid, when cut with a sharp edge tool, they cut into the two pieces without any irregular, with an irregular surface or without regular surface, with irregular surface or without a regular surface. They are, next one is, that is, they are true solid. Crystalline solids only called as true solid. Amorphous solids are not called true solids. They are pseudo solids. Pseudo means false solids, pseudo solids. Why? Because they can be pre-molded again. They are not true solids. That is pseudo solids. Otherwise, they are called as supercooled liquid. It's very important point. Amorphous solids are otherwise known as pseudo solids or supercooled liquid. Next one is anisotropic property of crystalline solid. What is meant by isotropic and anisotropic property? You just take the crystalline solid and measure some important physical property like electrical resistance, refractive index, electrical resistance, refractive index. These are some physical property. You just measure it in the case of the crystalline solid. In each and every direction we are going to get the different values of this physical property, electrical resistance. For example, in the direction of A dash, this is one direction, this is a crystalline solid. Atoms are arranged in this is a crystalline arrangement of crystalline solids. The atoms are arranged in a regular manner. This one, you just see that. Here this is a crystalline solid. It is a one lattice of crystalline solid. Here atoms are arranged in a regular manner. So blue atoms are here, then in between that red atoms are there, in between blue atoms are arranged in a regular manner. The blue, red, that is regular ordered arrangement. In this order arrangement, suppose I am measuring the property in this direction. That is the direction of A dash. In this direction of A dash. This is one direction. B dash, another direction. Suppose I am measuring the physical property like electrical resistance, refractive index in the direction of A dash. I am going to get some value, that is magnitude. Now I am measuring this direction, B dash, in that direction I am measuring. Suppose I measure in this direction B dash, I am not at all getting the same value where I got it in the direction of A dash. I am getting that different value in the direction of B dash. This value, both the values are A dash value, direction value is completely differ from that of B dash value. This different in that the physical measure of physical property like electrical resistance, refractive index are different in different direction in the case of crystalline solid. This property is known as anisotropic property of crystalline solid. Crystalline solids are anisotropic, but amorphous solids are isotropic. Just they have physical property, same physical property in all direction. There is an what is meant by isotropic. Isotropic, they are means here indicate amorphous. Amorphous solids are isotropic and have same physical property in all direction. That crystalline solids are anisotropic. They have different property in different direction. Why? What is the reason? In the amorphous solid, throughout the crystal that irregular arrangement. So because of throughout the irregular arrangement, in which direction we can measure, we are going to get the same magnitude for this physical property. But in the case of crystalline solid, this arrangement, suppose you have to take this direction, A dash direction means it only consists of red and blue in between. Suppose here you have to take me, so here you can see that what is that, alternately red blue, red blue, red blue, alternately this direction. This direction is not like that. Red is very closer to the line, blue is away from the line. But in this line you have to take the direction of B, B dash. Here alternately red, blue, red, blue, red, blue, alternately it is present. Here red indicate one kind of atom, blue indicate another type of atom. Either it is atom or ion or molecule, constituent, anything. So you have to measure different. Because of this direction we can get one value. In this direction we can get another value. The values are not equal. The physical magnitude of physical properties are not equal, means that is anisotropic property. Isotropic property means they have same physical property in all direction is known as isotropic property. Crystalline solids are anisotropic, amorphous solids are isotropic. Some common example for this crystalline solids and amorphous solids. Amorphous solids that is on glass, rubber, plastic, etc. Crystalline solid copper, silver, iron, common salt, zinc sulfide, potassium nitrate, etc. And anisotropic in the crystal is a different arrangement of particle along in different direction. And very important use of this amorphous solid. Uses of amorphous solid. Important use of amorphous solid. We are using this amorphous solid in different field, but very important use of this amorphous solid according to your exam point of view. Amorphous solid is one of the best photovoltaic material for conversion of sunlight into electricity, photovoltaic cell. There we are using this amorphous solids. Very important use of this